Hello, everyone. I'm happy to be joining training today from Charleston, South Carolina in the United States. And I'm going to talk a little bit about, well, I should say, so I'm the Chief Technology Officer and also founder at Pensavision, right, which developed the imaging technology that you'll be using today. And I was going to talk a little bit about how the device works, some of the ideas behind it, which hopefully will give you some insights into how to properly use it. And I also wanted to provide some overall general advice, as well as giving you some background on this technology, where else it's been used and how it's developed. So the technology, when you use it to collect an image, when you take a single click, what actually happens is that it's going to take a series of over 70 images. And each of these images are just like taking a cell phone image. Um, no more, no more, I would say, certainly no more high powered or anything like that in terms of the camera that's in there. This will take about a series of 3 seconds. So it's important that you hold it steady the throughout that 3 seconds while it's collecting images and ensure that it's held closely against the skin. Out of that, we collect or we store a set of images. So we get this 70 plus image stack. And using a lot of some sophisticated software, we take those 70 images, which are each one is just like an ordinary, cell phone image or ordinary camera image. But we can use that and generate a high precision 3D mapping, a 3D image that can capture measurables for things like cancerous lesions. To give a little bit of background also on maybe a little bit of the physics of it, the technique that we're using here, which is sometimes referred to as shape from focus, it's something that professional photographers have known about. Well, professional and amateur photographers have known about for a long time, which is that when you adjust the focus of a camera, you can bring the background into focus, the foreground into focus, a little bit like when you have portrait mode on an image, similar like you're seeing me, I'm in focus, the background is out of focus. And what we do is we use that focus information to determine the depth to every spot in the image. So same way your brain can tell if something is far away or close based on whether it comes into focus near you or far away, our camera can do that as well. And this is very different than most 3D imaging techniques, which rely on multiple cameras. Our technique relies on a single lens system. So it's one perspective, and it uses this mapping to take different images. The reason why we get depth information, of course, is that we're changing the focus between images. And to do that, we use what's referred to as a technology called a liquid lens that's being shown on the left of the slide here, that between images, we can very carefully change the focus. So we get a series of multi-focus images. And out of that, we can extract depth information. In a normal image, you might be able to see if something's, 1 meter further away or 1 meter closer. But with our camera and with our software, especially, we can actually see if parts of the image are a fraction of a millimeter closer or a fraction of a millimeter further away. And that allows us to generate a high precision depth map. Just to let you know some background, the technology that you're using today is actually part of 3 medical devices. So one of those is SkinScan3D that you're using today. Two other medical devices are ServImage and also E3D. Two out of three of these are part of patient studies this year. And in particular, ServImage, which is meant for screening of cervical precancers, is being used in Malawi as part of a 300 patient survey, 300 patient study that's led by my team. If you're also curious, Pensavision is all our technology is going to the International Space Station, which is scheduled for this June. And sorry, not this June, this April. And then there's a follow-up mission for a small satellite mission in June. So we actually have two of our cameras that are going up to space in the next few months. So our technology is used from Kenya, Uganda, and Malawi up into space. And we also use our device actually for industrial inspection as well, which is garnered actually some of the most interest in our technology. But to return to SkinScan3D, as I mentioned, we take this set of 70 plus images and we use an advanced algorithm that took us several years to develop to generate a 3D mapping. And the 3D mapping, as you can see here, looks something like this. So the data that you're seeing here was collected in a single click and took about 3 seconds to obtain that data. And then afterwards, you can take it, you can move it around, you can spin it, zoom in, zoom out. We also provide measurables, so you don't have to, just examine it and look at it. We also give you values out. But we do come up with this 3D precision mapping, which is how we're able to extract values like height and volume. Actually, so some of those values that are going to be outputted include information like volume, projected area, height, and color. And we'll output these all as quantitative values. So these, as you know, SkinScan3D is part of a longitudinal study. So you'll be able to compare each of these 4 values as they change over time. And for color, we'll use a quantitative criterion to do that as well. And each of these will measure. The 3D image looks nice, but this might be the information that you care most about in terms of tracking patient health. Some advice: it's very important to hold the wand still during that 3 seconds. Our technique works because the only thing that's changing is focus in between images. So we take all these high-speed images, and we know that only focus is changing, so we can combine them. If the device moves in between the images of that 3-second set, our algorithm very often fails because now there's an extra independent variable, and that's the movement of the camera. So it's important to hold the device very still. You will get a reminder of this when you're taking data. So this is what will appear on the console screen to remind you of that. Another thing, just to tell you, the 3D results that you're getting, they're not immediate. So the data has to be uploaded to a cloud server, and our team is going to process that data. And we need about somewhere around 24 hours to process it. This process is, in the future, will be automated, but that is taking us a bit of time to finalize that. And it's actually data that's being collected through training and through our initial study that actually helps us with that automation to ensure that the software that we have is well tuned, is well optimized to the type of images that it's collecting, or the environment, the image environment that it's experiencing. Okay. So just to summarize, please make sure to hold the wand steady while it's collecting those images. Also, another part I think I forgot to mention was to make sure the lesion is in the center of the field of view. That's where we have the best sensitivities. For training, ideally, you should train with someone who has previously used SkinScan3D. We definitely have much better results when that's the case, and we do have at least a few people at your training that should have previously used it. The results that you should expect to be outputted are a 3D image mapping, which you may or may not want to use, but we'll also output quantitative measurements of lesion volume, projected area, height, and color. As a reminder, those results are not immediate. They will need to be uploaded to a server, so the device console will need to be connected to the internet, so those can be uploaded, and then we'll process it. You don't need to have internet access while collecting data. You do need to have internet access while you are uploading the data. So I want to thank you for letting me join you today. And I and my team members are going to be online during training today. So we're going to make sure that we're available to answer questions, at least remotely, that may come up. And we're also going to be examining the data in real time as it comes in, to evaluate that that high quality data is being collected and that there's everything is going well as far as the instrument functioning well, and the users collecting good data. Thank you.